All right, we're on SBAC Practice Questions 2, number 8. So let's get right into it. Jose plays a bean bag toss. He stands at the starting point and throws the bag into a basket 10 feet away. The height of the bag, perpendicular distance from the ground, is a function of a horizontal distance from the starting point. The table below shows the relationship of the height of the bag and the horizontal distance from the starting point of the bag. So I kind of have to visualize things. So I see here's Jose, here's a basket, and I know that this is 10 feet away. He's going to be throwing a beanbag, and so it's going to do something like this. If I look at these, it says the distance in feet is 0, so at 0 feet away from where Jose is, the height is 2 feet. So I have 0, 2. When it's 2.5 feet away, it's 5.75 feet high. At 5 feet, it's 7 feet high, and so forth. That's kind of what this table is showing. If it helps you, you can put it like this. And now it's like a table, if you will. Okay. Determine whether each statement is true or false. So statement 1 says, the height of the bag decreased from when the distance went from 2.5 to 5 feet. So from 2.5 to 5 feet, it's saying the height decreased. Well, it went from 5.75 to 7 feet, so that's false. It actually increased. 2 says, the starting and ending heights are equivalent. So it started at 2 feet and it ended at 2 feet. That is true. Number 3, the highest point reached by the bag was 6.8 feet. If I look here, the highest point that it reached was not 6.8 feet, but 7 feet. So this is false. All right, moving on to number 9, it says determine whether each function is exponential growth or decay. So remember, a exponential growth and decay function looks like this, and if b is greater than 1, then it's growth. If b is less than 1, then it's decay. So that's what we're going to be looking at. What's inside here? What's b? So b here is 3/4, and that is less than 1, so that's decay. Okay. The next one, 7/4 is greater than 1, so that's growth. 2/3, 2/3 is less than 1, so that's decay. 5/3, 5/3 is greater than 1, so that's growth. And last but not least, 1/4 is less than 1, so that's decay. All right, let's look at number 10. Number 10 was like one we had on practice 1. It says select the graph that shows the solution. So first I'm going to write these in y equals mx plus b form. So I'm going to subtract the 4y over. So I have minus 4y plus 2x is less than or equal to 2. I'm going to subtract the 2x over. Minus 4y is less than or equal to negative 2x plus 2. And now I'm going to divide by negative 4. Anytime I divide by a negative with an inequality, I have to flip that sign. So I flip that sign, and a negative over a negative is a positive. 2/4 is 1/2. And here a positive over a negative is a negative, and 2/4 is 1/2. So my first line is this one, and my second line, let's go ahead and write that in y equals mx plus b. I'm going to subtract the 3x over, and I'm going to get y is greater than negative 3x plus 4. Both of these are in y equals mx plus b, so let's graph them. Start with the blue one. I should be at negative 1/2, and I should go up 1 and over 2. This looks like it went up 1 and over 1. Let me zoom in a little so I can see better. So it should be at negative 1/2. Oh, sorry, up 1 and over 2. Yep. There we go. And it should be a solid line, which is what this one is. That's good. And where do I shade? I'm going to shade up. So this one actually satisfies the line. That means that all of these, so this, and we should have shaded up, which we did. Good. It should be here, and we should have shaded up, and it looks like we shaded down. So we know it's not C. Not going to be C. Here, and we should have shaded up, and we shaded down, so it's not going to be D. So the only two we're looking at is A and B. So zoom out a little. There we go. Now let's look at B. Or sorry, the second line. Y is greater than negative 3x plus 4. So I should be at positive 4. And I should go down 3. 1, 2, 3. And over 1. Good. And it should be dotted. And if you look, it's the same on both of these. So that worked. It's where do we shade though? So here we should have shaded where y is greater. Y is greater up here, and it looks like they shaded down. So it should actually be here where y is greater. So we have B is our answer. And last but not least, let's look at 11. It says the graph shows a quadratic function f of x and a cubic function g of x. Select all values that approximate the solutions to the equation when f of x equals g of x. So remember, when f of x equals g of x are not the zeros. They're not these points of the function. Or if we were talking about the quadratic, it's not this point here. It's actually where they intersect. So they intersect at this point here, this point here. Those are the points where they're equal. So let's find for which values, it says select all values, not the points, but select all values that approximate these solutions. So if we're looking for the values, let's see, we have about here, just below negative 1, or just before, and just before negative 3. So this one looks like negative 2.9, so I see that here, and this one looks about maybe negative 1/2. Oh, well that one says 1/2. It should be a negative 1/2. Let's see if there's any other that match. This one does not, this one does not, this one does not. So this is just a typo on my part. That should be negative 2.9 and negative 0.5.